Here is my erosion bottles experiment. We started with the engineering design process. We asked how we can begin with the study of soil and land cover, the impact of the infiltration and runoff system. To do this, we used the Stroud Water Research Center PDF. I imagined how I wanted to use this PDF to create this simulator. And in order to do this, I looked at the document as well as the simulator that was provided by Dr. Dietrich. I planned out what I wanted to do using the PDF. I collected all of the materials that I needed and gathered everything that I would need to create the runoff system. Next, I created the system using that document. Each step, I started with cutting holes in water bottles, filling them each with soil. One I added grass seed to, watered it each day, and watched it grow. And another I left plain, and the last one I added mulch. I let the grass grow over a week's period in time. If I were to improve this next time, I would create the erosion bottles with the grass seed sooner because it didn't seem to work within a week's time. It seemed like it took longer for the grass to grow. While I was completing the assignment, I needed to improve the amount of water. Sometimes it was too much or sometimes it was not enough. This connects to the PA Environment Ecology Standard 4.210A. Examine the interactions between abiotic and biotic factors within a watershed, and then below a substandard is to describe how vegetation affects water runoff. Here is my design. I started with cutting holes in 3 water bottles, added soil to them. Then I added mulch to one, left one plain, and added grass seed and would put water in the grass seed one each day. And eventually it looked like this. Here is the end results. My end results show that the mulch and soil combination produced the clearest runoff. The soil produced the most polluted runoff. And the grass and soil combination produced some runoff. I think if the grass was planted earlier than a week before, the grass would have been more mature and developed more of those roots that would have implanted in the soil, so it would have been able to help clear some more of the runoff. Connecting this to the readings, the figure on page 538 connects to the engineering design process, the science to plan and carry out investigations, technology to recognize the role technology plays in the advancement of science and engineering. Engineering, it's to plan and carry out investigations, analyze and interpret data, and mathematics to use appropriate tools strategically. It also connects to the readings because STEM provides a challenge to students, teaches 21st century skills, integrates subjects, provides relative examples to the real world, as stated by Vasquez. STEM as a whole also needs to be integrated seamlessly in order to strengthen each other and the connections among the fields that STEM offers, also stated by Vasquez. And lastly, STEM is meant to become a progression in which students learn more from year to year. So I felt like this activity was definitely connecting directly to our Vasquez readings because it provided that challenge. And those 21st century skills integrated the subjects, provided real world examples. It was integrated seamlessly, and it was meant to become a progression. Thank you.